Yeah, so my project was the extracting hydro data from multiple LiDAR series. The overview for my the paper was the collaboration pilot areas LiDAR. We had our goals, our methods, results, and the future steps. So the collaboration was a contract from the USGS. We actually started working on this in the fall of 2014 to kind of take the PA map LiDAR series and try to extract all the hydro data set pieces, but the USGS wanted to fund this more proper so we could do a pilot watershed. And so we worked with IUP for myself and Bob Wilson. PA Magic and Lancaster County provided a lot of data for us to use. And we also met up for any data observations for the past year, data collection, and we also discussed what next steps we had to take in the process. So the pilot areas were the Miller and Swar area on the west side and the Muddy Run watershed on the east. And this area was actually chosen because of Hurricane Sandy. PA map was done in 2006 and 2008, but there was new LiDAR created for just Lancaster County, or well, surrounding areas, including Lancaster County. And we chose the watersheds because of the different terrains. So Muddy Run's more farmland, and Miller Swar provided a bigger challenge because of sloped areas, and Route 283 could impact the DEM processing. So the LiDAR digital elevation model we downloaded from PASDA. So PA map is a QL3 quality level 3 based on USGS. It's a 1.3 meter resolution. And the Sandy LiDAR, which was taken for Lancaster County, was a quality level 2 at 0.7 meter resolution. Unfortunately, because of the PA map system, we wanted to compare the two because a lot of the counties now in Pennsylvania have PA map data for DEMs at almost 10 years old, which, in technological terms is kind of obsolete at this point. But we did use that for comparisons. So our goals was to generate flow lines, and we wanted to improve the NHD data set by submitting any flow lines we created and compare the differences between the DEMs. So the background of this map is the DEM itself, and there's three, there's a mess of different flow lines occurring in this map. And we also wanted to attribute the final flow lines that we could submit to the county themselves, and then this could be submitted to the NHD. So some pre-processing steps that we wanted to do just for the DEM before putting it through a model and creating the final flow lines was to implement a break line. So the yellow line actually represents where the process was just made from the DEM itself, no break lines were implemented. But we noticed that it was actually following road features, not going under bridges, not taking any culverts into consideration. So the field collected different break lines. We also did an intersection between streams and roads, just to kind of examine where bridges might occur, where culverts might impact streams. So we actually improved the flow lines in the end in that teal line, where it actually went through the road, bridges, and followed a lot better through the dark lower elevations. We also did calculations for acreage. So we had a choice in the model, which I'll show in a couple slides, where you could break down the limitations of the final flow lines by either grid code, which is a stream order, so you can limit it by first, second, third, fourth stream order just based on the processing. And then we could further change the distance between the starting points of the flow lines based on the acreage. So we did a calculation that was borrowed from Allegheny National Forest. We took the 4,046.86, which is just the square meter acre calculations. We removed any null values after the calculations, calculated to an integer, and then removed further values that were less than a number of acres. So this is the hydrology model at its full scale. But to examine it further, the power behind this model is that there's a branching step utilizing Python in the model builder to allow the user to choose if they wanted to do acres, if they wanted to do grid code, and we also allowed them to create a basin, which is on the left side of the model. And the lower side is basically, the calculations of the acres and the final steps that were involved in the basin creation. And the parameters that were involved in the hydrology model itself was the raster itself, the choice between creating a basin or not, the use of acres or grid code. Then you specify how many acre drainage you wanted to use, what grid code you wanted to choose. So it would, if you choose the acres, it would only borrow the acreage number. If you chose to not use acres, it would use the grid code number. And then, of course, the output name would automatically fill in any parameters in the geodatabase. We also wanted to create watersheds based on the flow direction, the user placed pour point, and the flow direction. So the basin that was created from the hydrology model, it created this light blue here, but it doesn't conform very well to the watershed itself. It only bases its polygon creation off elevation alone. So we wanted to allow the user to place the pour point from the model creation. The number is, if you wanted to choose a different point for the pour point, because it saves the geodatabase information in different numbers. And then, of course, the flow direction is kind of the elevation. Each cell has an elevation direction, and the flow accumulation gives you the flow. So this is the results that you can get if you run all of the models with one of the DEMs. The top one, the light blue, is the basin creation. The dark blue is what is created after you use the watershed using the pour point. Of course, the flow lines are visible. The flow direction, as I mentioned, each cell has its own flow direction based on a D8 model, and the flow accumulation utilizes a sort of stream order to determine what order the flow goes. So the results, as I mentioned, these were the basin just uses the elevation. The flow direction and flow accumulation were pulled up specifically from the hydrology model, and the polygons from the watershed used a little more power behind creating them. So some watershed comparisons that were created. We tested 4 digital elevation models at first. So we used the bare earth that was created from the 2014 LAS. We used the bare earth with a lower point spacing. So the original bare earth, we used a 3.2 point spacing. And then we used the PA map 2008 data and the QL2 LiDAR from Sandy LiDAR that was provided to us. And this actually didn't use break lines at first. So this, you'll notice that one point in the QL2, this orange line that cuts off the northern part of the watershed for some of the polygons, actually follows the Route 283, which is a huge impact of the watershed creation. And then we also took field collected channel heads. So we had hydrology data set from Lancaster County, and we had a couple people go out and kind of look at each of the starting points for all the flow lines. And we did a near calculation and a route calculation to see how far away each of the points were from the nearest channel head. So we actually determined from just doing the near calculations, and we kind of wanted to gear towards the 2014 data already because of the updated imagery. So we decided to use just the 2014 provided data with incremental break lines. So the results from using this 2014 data, we wanted to categorize or symbolize it by the grid code. So this dark line is the stream order 5. This is light is the number 1, so it's going toward the end of that eastern side of the watershed. And so we try to make it as well so that we could select that entire 5-order stream without it being segmented, between each of the grid codes as well. And we also did an attributed where we where I went in through and each, zoomed in, looked at the aerial, said, okay, this is a stream, this is impacted by road. We're not sure why this is done, might be just because of drainage, any culverts that were utilized, and then we also showed the different flow mismatches, and we used any other places that might be a flow possibility. And to zoom in a little further, it's a little hard to see the stream on the southern side, but you can kind of see how they're categorized by the aerial imagery, where there's this yellow line where it's not where a stream occurs, and this red line shows where it doesn't actually conform to the stream. And then when we take away the unknown extensions in the road impacted flow lines, you get kind of a similar thing that we got from the Lancaster Hydro, and something that's attributed that we could go further into and look at to kind of finalize this and submit it for the NHD and for the Lancaster County to utilize for themselves in this area. So the future steps, of course, we wanted to verify the attributed flow lines, and in the next couple of weeks we want to test out another watershed area where it only uses the 2008 because it's in Lebanon. And it will test the model's processing power for DEM tiles because it's 65 square meters or square miles large. And then we'll also track the time used because the original processing kind of was mix and match. We went through each of the steps, but we didn't really document the times as much. And then, of course, we need to submit a final report to the USGS for a contract. And that's it. So is there any questions?